Alright guys, we're going to go ahead and get started with our last round of exit tickets for this week. So, starting with passage 3. According to the passage, electron pairs tend to. And remember, when it says according to the passage, then we tend to look here. So, molecular geometry. Vesper uses Lewis dot structures to predict geometry of covalent bonded molecules, electron pairs, non-bonded pairs. So, let's see. Vesper theory states that the shape of molecules is determined by repulsions between bonded and non-bonded pairs of electrons. They arrange themselves as far apart as possible to minimize repulsion. So it said in the passage, so that's where you actually read the intro blurb. Because it'll say scientist 1, student 1, scientist 2, student 2, and that's where it wants you to look. So, arrange themselves as far apart as possible, or arrange themselves. So they arrange themselves as far apart as possible. That's a direct quote from our passage. So, D. 16. Based on student 2's explanation, so we're going to go to student 2. The south end of a magnet will repel the south end of another magnet because student 2, let's see, is also dependent on the presence of electron pairs. The non-bonded have a negative charge and therefore repel the electrons that are bound to the atom also. Because one molecule has two non-bonded and a central, then it is tetrahedral. So let's see. Positive charges always attract each other. Does not talk about positive charges at all. Negative charges always repel each other. Does talk about that, so we'll leave G as an option. Positive and negative. Doesn't mention positive ever. So at no point is positive mentioned in the passage. So G is our answer. Alright, 17. Suppose a molecule of sulfur dioxide, SO2, was found to have a bond angle of 120 degrees, contain one non-bonded electron pair. So, bond angle S, O, and O, and that's 120. There's going to be double bonds and stuff here, but that's okay. If true, this finding would support the viewpoint of student 1. Predicting the shape is relatively straightforward. A molecule's shape will always be determined by the number of electron pairs around the central atom. The number of electron pairs corresponds to the number of atoms that are bound to the central atom. 2 hydrogens bound to 1 atom oxygen, giving it a linear geometry. Okay, so this one is saying that the number of atoms equals the number of things here, but this one has an extra non-bonded. So, the one that talks about non-bonded here, where does non-bonded show up the most? And we talk about that in student 2. So the answer to 17 is B. 18. Quantum mechanical models of that sulfur hexafluoride. Quantum mechanical models suggest that a molecule of sulfur hexafluoride contains no non-bonded electron pairs. Both students would predict that a molecule of SF6 would have what? So it has no non-bonded electron pairs. Let's see. Molecule shape would be determined by the number of electron pairs around the central atom. So this one is SF6. So that's like, there'd be 6 thingies. Make that symmetrical. Now, which one would talk about 6 thingies here? Contains 6 electron pairs around one central atom. So the answer to 18 is F. So that's where you have to go back and look at the shape. So read for a number of electrons. Okay. 19. Suppose that the model presented by student 1 is correct. Based on the information provided, what would be the bond angle in a molecule of perchlorate? So Cl, and we have 1, 2, 3, feel minus, so we have an extra electron. Okay, so it's like, instead of 7, 8. So let's see. We have our extra electron here. Now, let's see. The central atom is surrounded by 4 electron pairs. I guess just the O has an extra electron. So it would still be that. Our central atom has 4, because there's 4 oxygens. So you take your chlorine, 1, 2, 3, 4, which you can do because you take away that extra electron. So let's find the number with 4. 4, so that's 3. That's 4. So we're looking for a tetrahedral for the most part, but we need the bond angle. So let's go back to tetrahedral. 109.5, 109.5. All right, just a couple more. 20. Based on the model presented by student 1, a molecule of ammonia would have. So I have N, H, 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 because there's 3 of them. Trigonal planar because 3 atoms are bound. So, well, we don't draw the unbonded ones for student 1. Student 1 has no unbonded. Okay, so that means we have 3 central atoms, or 3 side atoms to a central. So 3 around a central, bond angle of 120, that's trigonal planar. All right, trigonal planar, check, 3, 1, woo. Our answer is 20. 20 is F. All right, last 2 questions. Which of the following diagrams shows the relationship between an electron pair's bonded status and the strength of the repulsive force? Is consistent with student 2's assertion about the shape of a water molecule, but is not consistent with student 1's assertion. So this is actually a very loaded question. This one is very hard. So let's see. Student 1 says it's linear. Student 1 says it's H-O-H. Student 1, for the record, is wrong. And this one is tetrahedral. Let's see. Because one molecule of water contains 2 non-bonded electron pairs and a central oxygen atom, and 2 electron pairs, it has tetrahedral geometry. So we're thinking about H-O-H and H-O-H. Okay, so here we are. That this would have this angle, so this is 180. Okay, so which of the following diagrams shows the relationship between an electron pair's bonded status and the strength of repulsive force? So, but is not consistent with student 1's assertions about the shape of a water molecule. So let's see how strong their repulsive forces are now that we have them drawn. The number of electron pairs corresponds to the number of atoms. The geometry is also dependent on the presence of electron pairs that are not bonded. Let's find repulsive force. That the shape is determined by the repulsions between bonded and non-bonded electron pairs. Okay, so let's see. Student 1 has these 2, and then this one still has 2 unbonded. So if we're at bonded and unbonded, if these are our different ones, these are actually the same because it's 2 and 2. So we need something that shows me the same. So that would be answer D. And finally, 22. If you got this one wrong, this question is really loaded, so don't feel bad if you got it wrong. Be happy that you tried. If you guessed, then feel bad. All right, 22. Measurements made through X-ray crystallography show that the repulsive force of non-bonded electron pairs is greater than the repulsive force of bound electron pairs. So this one is saying that bonded. So let's say if this were bonded and unbonded, right? This is what it was saying. Based on the information provided, so the repulsive force of non-bonded is stronger. Based on this would weaken the following viewpoint of which ones. So if we go back to our answer in D, where we don't really talk about the repulsive force, changing here, that would actually weaken both of them because it would change both of their arguments. And that's that.